Today we're going to be talking about the trig equation, the trig function, y equals tangent 2/5 pi theta. Specifically what we're going to try to figure out is where are the asymptotes, especially where are those asymptotes that are not the period that usually we can find when trying to graph this. So we can think about that sort of like the central asymptotes. To get a better handle of this, let's think back to our usual graph. So pretend that the 2/5 pi is not there, just regular tangent theta. So we know there's, if we zoom in on one asymptote, the one that's around the x-axis, I'm going to call sort of like the central little cycle. Where would these asymptotes, these fences for that snake that's slithering up, where would they be located? Well, wouldn't this be pi over 2 and negative pi over 2? Because you can't do tangent at those locations. Okay, now let's think about what does this thing actually do? Well, this spot is for the A value, our amplitude. This is the B. This is the thing that messes with the period. But what is the period down here? Well, if you wanted to count, this is pi over 2. This is pi over 2. We have to think about what do we get when we add those two values. So let's do that. So the period's going to be pi over 2 plus pi over 2, which is the same thing as doing 2 times pi over 2, if you wanted to do it that way. Either way, we get pi, right? Okay. So now let's use this value of pi, which we're going to alter by doing the 2/5 to it. If we were to do that, we know that the B value, we have to divide our original period by 2 pi over 5. Well, when we divide, we're just doing KFCing it, right? We're keeping it, you're flipping it, you're changing it. So that's going to be pi times 5 over 2 pi. The pi's cancel, and you would get 5/2. Let's flip to the other board, leaving this in case we need to refer back to it. We don't have to rewrite it. Just leaving that portion. So we have that 5/2, right? What does that represent? Well, in our function, which, just to remind you, y equals tangent 2/5 pi theta, we now know that the period is 5/2. Well, how do we use this to determine where those dotted lines are at, where those asymptotes that are keeping the slithering tangent in place? Well, we need to cut this in half because we know that the y-axis is going to be right there in the middle. We haven't moved anything side to side, so we can do this easily. We're going to do our division again. Well, 5/2, you multiply, you flip, that would be 5/4. This would be our end asymptote. Our start asymptote, the one to the left, would be the negative of that. So now we know that we have this. Switch colors so it can pop a little bit more. I know that this one is negative 5 over 4. I have another one over here, symmetrical, which is 5 over 4ths. So you can see that 4. And we know that the tangent would be in the middle. This is the amplitude, so I need to go up to 1, down to negative 1. So we're going to have it right here. You guys from class know that I need to stand to the left because it's easier for me to draw things. In this fashion, we have the snake slithering up. But guess what? This one is one of your options for the multiple choice. However, that one's not on there, so what would you do? Well, what happens is you're going to have to be able to find another asymptote, either further to the left or further to the right. We're going to go to the right. As a hint, that may be the direction in which you're going to need to search for one. Well, this distance is 5 over 4, so I need to add 5 over 4 to this, which would be 10 over 4, right? So if I go the same distance this way, so around right here, this would be 10 over 4. And at this location, you would get another little slithering snake. You need to break up your things into different pieces. This is our 0 point. Nothing's been moved over. The amplitude, let's line it up right there. The snakes are the same sizes. Right here goes down right here. Let's see if I can do it. Yeah, I managed to do it. Okay, 2 snakes in between the same fences. And then these would be our asymptotes that we were given. That one's still valid, and you can add another 5 over 4 and get another one. Or you can subtract 5 over 4 to go that direction and get negative 10 over 4. So this is how we would take tangent of 2/5 pi theta, finding its period, splitting it in half, to then find the 2 central asymptotes, then find one to the right or one to the left if needed. Usually you're just going to need these, by the way. But if you need more, this is what you do. You're going to add this distance over and over again until you find the ones that match.